So this is just a short video to provide an overview of the Pixel screen. I call it the 4K screen. I think it's near 4096 individual pixels, roughly a 4x8 sheet of plywood size. The material was the plastic was I believe it was Holiday Coro. I got that from. It was marked down because of a regular hole spacing. So I said, why not? That wasn't the real cost. The real cost is in all these pixels. So I built a PVC frame, which I'll lay this down. Because of the weight of the pixels themselves, you can see it bowing across the bottom. As it's hung vertically, it just pulls down. So I'll try to offset that. I grommeted across the top here because the holes provided in the plastic, which I zip tied, are just far too weak. So I went with a grommet system, some paracord. It's pretty sturdy stuff. Weaved along, sort of self-supporting. Has it made a big difference? Probably not. Still, you can see the eventual settling of the screen on the weight there, or by the weight. So if I lay it down, now this thing is not light. This thing's probably 100 pounds, give or take. So if we look along the side, so I took PVC 1/2 inch, no, 1.5 inch. I think it's 1.5 inch. Just measured it to the width and length of the material. Put on some 90s. Attached it all. Now the key device here is I took stainless steel eye hole bolts and I put them through on both sides. And this is where the weight is applied, or that is it is hung from the left and right sides off of this, which is put vertically through. And then meanwhile, I've taken some 1/2 inch nylon rope, wound it through, and then it attaches to this device, which is the top mount for this screen, which the top mount is connected to an eye hole at the apex of the roof. So it has 3 support connections, left, right, and center top. The center top actually is connected to a pulley that allows me to pull this up, and I'll show that in a second. But because of the sheer weight and size, I have 3 cross braces to try to keep the structure semi-rigid. And meanwhile, you can see, the actual pixels themselves are tightly spaced, and they go, I can't remember because it's been some time, but I think they're roughly 500 to 600 per line. That is per control line. And it just so happens that they sort of conveniently work out that I didn't have to do much cutting and splicing. These are all Raywu WS2811 12 volt resistor-based pixels. I've got 8 driving lines and 2 power balancing or power injection lines that come in on this left side of the array. So everything starts and ends on the left side, and then when it's hung, it can be accessed down on this lower corner. So everything connects down in that lower corner. And in a previous video, I showed how I put together the Harbor Freight ammo can box with the Culp K32A-B. So power injection is done by tying. So if there's 4 runs on the upper half of the array. I've taken the ends of those 4 runs and tied them into the power injection line. And then I feed the power injection line right here, top, with 12 volt off of the 2 Meanwell LRS 350-12s. So I'm trying to inject at the same point on the upper 4 lines as is the signaling and 12 volt coming in on the front of those lines, or the beginning of that sequence. And I do the same on the bottom half, power injecting at the end of the runs as well as being fed by data and power at the beginning of the runs. So that is sort of the array structure, and I'll just do a quick. So this, when it's stood up and it's moved, it comes out and the control box is up here in the upper corner of the garage, and wires come behind the garage door. I use aluminum tape, and they are flushly bent around the top of the garage door. And you can see some fixturing I had done because I previously hung this in the garage door the first year I used it. But this year, I'm sorry, last year and the years to the future, it's now hung centered above the garage. And to do that, because of the tremendous weight, there are multiple attachment features. There's the left, there's the right, and then there's a center eye hole. The center eye hole has a pulley attached to it that is then connected to the device, the triangle device here, which this is from Harbor Freight, and it's the pulley system used to hang a deer. So it's just repurposing a pulley that's generally used to lift a 300-pound deer off the ground to lift a 100-ish pound pixel array. And so I pick this up, I bring it out here, I connect the pulley system. It's sort of set vertically, and then I stand behind it and I crank it up slowly and carefully. And once it's raised to the right point, I tie off the nylon line down on one of these eye holes. I go up on my ladder and I physically connect the left side to the eye hole, the right side to the eye hole, and then I come down and I take the rope and I tie it up so that it's stable for the remainder of the winter. And so that's the process to get, you know, a 4,000 pixel array up above your roof. And I can do this all on my own. Probably not advisable to lift that all, but with the pulley and the sort of slow methodical process, it works out. And I think that's about it. This has been used for 2 years straight, one bad pixel out of 4,000, and otherwise has been beautifully. And I drive these at 10% brightness, because in aggregate, when you have 4,000 pixels in close confinement like this, it does not need to be very bright. It actually becomes so bright that it overshadows the roof lines, windows, and other parts of the show. So if you come up, you're like, wow, that's a bright display. So I tone it down as best I can, and that helps with the power, the voltage droop, and the overall operation of it. And it's very visible from the road, down at the end of the driveway in the surrounding cul-de-sac area. So here, I'll just pick it up. Just finished with that. That's what it looks like.